Hello everybody and welcome to today's webinar. I hope you find this presentation educational and helpful really in evaluating your organisation's use of metadata and what you could possibly do in the future. So just a bit of background, my name is Michael Pay. I'm the Chief Technology Officer at Concept Searching, where I've been for a couple of, 4 years now, and I head up our UK-based development team. So what we're going to look at today is the different aspects of metadata and a comparison of the various technologies that can be used to enhance metadata within your organisation. As part of this, we'll take a look at a few different demonstrations and discuss the ways in which auto-classification can support the whole life cycle of document management. There were a few questions posed via the online registration page prior to the webinar, which what I'll try and do is incorporate the answers into the presentation. But if you have any additional questions, feel free to type them into the chat box, and regardless, we will make sure that we get back to you after the webinar, whether or not we sort of incorporate them into the presentation as well. We will also be recording the whole webinar, and we're going to send a link of the recording and the presentation to all registrants later on. So for those of you just very quickly that don't perhaps know who we are, we've been around for around 14 years and we're focused on metadata generation, auto-classification and taxonomy management, and we've got quite a lot of the world's largest corporations deploying our platform. So our software is platform agnostic and not a SharePoint only platform. However, you will find that a lot of the content of this webinar does focus on SharePoint because we do have quite a native integration with it. So we support all versions of SharePoint from 2007 onward, with full product support in the form of both a farm solution and a provider-hosted add-in. We're also the only solution in the marketplace with a fully integrated statistical multi-term auto-classification platform, which we use to deliver metadata-driven search and governance solutions to people around the world. So as a core platform, what we like to focus on is 3 key areas: metadata generation, auto-classification and taxonomy management. And we provide all of this functionality, as I mentioned, with native support for SharePoint infrastructure. However, the flexibility of our product is such that we can be used to categorize and analyze content in many other content repositories such as files, databases and websites. And what our engine can really then be used to do is generate semantic metadata to deliver enhancements to many business areas such as search and migration. And what this ultimately allows us to do is eliminate the end user tagging process unless the end users are explicitly allowed to do so as part of the business process. So the question is, why would we be looking at metadata and what are we going to do with it? And I'm really quite keen on this particular statement because I think it drives home the importance of how accurate document retrieval is needed. If we're making business decisions based on content that we can't accurately retrieve, then ultimately the business decisions can't be relied upon. So we need to be able to get our documents accurately. We also know that unstructured content is growing quickly. I think perhaps what's surprising is how quickly, even exponentially, the level of content is growing. And with this level of content, what comes with it is the fact that it's unrealistic to use manual tagging techniques, not only due to the unreliable nature of end-user tagging, but also due to the sheer time required in manually processing this level of content. The impact of this at the better end of the scale is simply some poor search, but at the worse end of the scale there's a serious increase of risk in the industry and non-compliance. So here's a few of the applications that we consider metadata critical, and what we're effectively saying is you either have a choice to manage them or to simply leave them as they are, knowing that eventually the lack of metadata will impact the processing and functioning of the applications, even if it's not immediately obvious. As a case in point, what I'll quickly look at is migration. Now, many organizations are currently looking to invest in cloud solutions around the world. And in doing so, what they're needing to do is take terabytes of data that they've currently got on file systems or perhaps SharePoint on-premise systems and migrate them up to the cloud. A simplistic view would be that we could just take a crowbar and lever the whole content set into the cloud. But what a more sensible approach to do is take automatic metadata generation and identify our old data, our duplicate data within the content, and then our unnecessary data. And what we can do by doing this is drastically reduce the migration costs, both in terms of time and licensing, And once the data has hit the cloud, what we also have is an immediately better search with less data to worry about and reduced costs in hosting the migrated content in the cloud. Because I think it's key to remember that when we're sitting in the cloud, we're paying gigabyte by gigabyte. So it's important to keep that in mind with content that you're taking up from your on-premise servers. So the next question is, if we're sitting in a situation where we're not currently using metadata and we're going to a metadata environment, we need to be able to prove that there is actual benefit in it. So how do we measure the performance? The thing about this is performance as it applies to search is quite tricky. Most search engines can be tuned to some extent, but what most organizations do is leave them as they are. And furthermore, retrieving the use of search results is time-consuming and difficult. So what we tend to use when we measure performance is an analysis of precision versus recall, which is a fairly standard term in the search industry. Precision defines how accurate the results are based on an input query, and recall defines how many results are retrieved for each input query. And what happens is if you focus too much on making your search or classification results as precise as possible, you risk little or no documents being returned, which isn't particularly helpful for the end user. Equally, however, if you focus on recall, what you risk doing is that the search returns far too many results and the end user becomes jaded and frustrated, having to go through almost as much content as if you didn't have it. So in an ideal world, what we're aiming to do is balance these two characteristics as much as possible, and we can measure our performance based on those individual characteristics of how much content is returned for each query and how accurate each of those classification or search results are. So there are some vendors out there, including ourselves, that will generate metadata automatically. Some of the solutions require complex Boolean expressions, which can be useful for some business cases, but can be difficult to explain to business users. And what that means is you end up using IT resources during the business refinement stages. And the difficulty with that is obviously the business owners are the ones that have the knowledge of actually the content that you're processing. So they're the ones that are best placed to be able to explain how the search should return results. The IT team typically have to work across large areas of the organization and may not have that knowledge. Equally, some products require large training sets of data to begin the classification process. And these sets of data may be difficult to create, which takes a massive amount of time and delays the organization's return on investment. Finally, there are linguistical techniques. Now, linguistic techniques typically don't scale well. And the reason for this is that they can have a sort of a black box nature. They do return content that might be relevant and might be accurate, but it doesn't actually necessarily align with the business requirements, and there's not always an easy way to identify why they don't align with the business requirements. So what we really recommend is an enterprise metadata repository. And what this enables us to do is manage all of our metadata for our organization in one place. We don't necessarily have to have all of the metadata being managed by the same person, but it should be stored in the same repository, and then your relevant business owners can manage each element of the repository. So what this solves is the issue of applying policy across the whole enterprise by ensuring that we manage all of our policies in a central location, and then as our policies evolve over time, we can deploy those very easily to all of our content repositories. Now going back to basics really, metadata is sometimes defined as data that describes other data, but this definition is not overly clear. Metadata itself can be gathered from several different sources. The document itself contains metadata, such as perhaps the file size or the author, but metadata can also come from other sources, such as auto-classification products or perhaps manual tags that were added by someone else throughout the process. So we break down into 4 defined models of metadata. Most organizations are using intrinsic, administrative, and descriptive metadata, though they may not realize they're using it or use it to improve their document management. A metadata generation tool typically focuses on the semantic metadata model, which leverages all of the unstructured content and can also leverage the other 3 models to enhance the precision of its results. One of the problems we typically face is that when we're managing content, upper management doesn't always understand the financial repercussions of poor metadata or poor document organization. In a recent survey, we found that 93% of organizations want to improve search and are working on their content lifecycle management, yet 91% of them are using manual tagging, with a number of issues as illustrated by this diagram. The first issue we get with manual tagging is inconsistency. This might be because business alignments change over time, so the tags that were applied on day 0 are not relevant on day 100, but it's also perhaps due to the subjective nature of tagging. A user in HR is likely to choose vastly different tags to a user in the technical department. The second issue is expense. The process of manually tagging documents takes an incredibly long time. And finally, malicious compliance. And what we mean by this is that an end user may say, okay, I have to select a classification value for this field, but what I'll do is I'll just select the first value in the drop-down list, or I'll leave it as the default value, or I might just select the same value for every single document. And this makes it almost in a worse situation because you have the metadata, but you can't trust what you're seeing. And that's why auto-classification and consistency is so important. So what we found is that metadata is the glue that enables our auto-classification and our robust taxonomies. A single repository enables metadata to be managed all in one place, and policy can then be applied consistently regardless of where the content resides. And it's also flexible. We can make changes to the taxonomy in alignment with business goals, which can then be pushed out and immediately available to all of our repositories, unlike our manual tags, which are static at the date that they were created. So what we're going to look at now is how we can extract terms from our documents in the way that I mentioned earlier in the slide, so that we can start looking at how perhaps we could apply metadata automatically using both individual words and compound terms, which is one of our key areas of our product, in terms of identifying content as a particular subject. So just bear with me a moment while I bring up the demo environment. So what we're looking at here is a view of a taxonomy classifying content to a term called environment. And at the moment it's a very simplistic keyword match. What we're looking at is saying if a document contains the word environment, then it absolutely must be about environment. But this is a bit of a flawed analysis. We're going to have content that perhaps doesn't contain the word environment, but actually definitively is about environment. It just doesn't happen to explicitly mention it. And equally, we may have content that says the word environment once, but actually is about something completely different. So the word environment perhaps shouldn't be considered such a strong indicator of the fact that it's about this particular topic. So the way that we can try and deal with this on an automatic basis, rather than an end user having to sit there entering manual terms and defining all of this in a very lengthy fashion, is do an analysis of the content that we have already in our index. So the way that we're going to do that is find all the documents that contain the word environment and then do a reverse statistical analysis of all of the content that contains that word and find the relevant individual words and the relevant phrases that are particularly statistically relevant within that term set. So if I drag environment in here and then click suggest, that's going to then drag out a load of different results. And as we scroll down, we can see some that are perhaps less relevant, but perhaps exist in some documents repeatedly. So we've got some here in Welsh that are probably less relevant. But what we can see is a number of terms that the end user perhaps wouldn't have thought to add, but are definitely something that we could use as part of our building of clues for the term environment. So we have wildlife order, we have environment order insert, Natural Environment Act, Game Preservation Act, and built environment. And the important thing to note here with our particular product is that we're not only pulling out those individual words, but those compound terms. And the individual word environment, this is why compound term processing is so important, because this individual word of environment on its own could be in any kind of context, whereas when we have these compound terms, it's very explicit what that particularly means. So it's much more accurate in terms of giving our classification results. And in terms of recall, by adding lots of different clues in, we give ourselves a nice coverage across our document set. So we could then very easily select these new clues effectively in terms of our auto-classification and apply those to the rule set so that going forward, any documents that don't contain environment but do contain all of the other terms can be used. One other point just to mention while we're here, you will of course notice that one of these clues does contain environment order insert, which by definition has the word environment in it. The benefit of having both of these clues is that what we could do is say, well, if it contains the word environment, we do consider it to perhaps be about the topic environment. But let's lower the weighting of that importance. So let's set the weighting very, very low. Therefore, it has a bit of a bearing on the application of that metadata. But if we find environment order insert as a compound term, that has a much higher importance. So we'll take that across as a very important term. So what I'm going to do now is switch back to the presentation. So what we're saying is that now we've built up our clues and we've got our metadata under control, the question becomes what we're going to do with it. Now, most products will provide a taxonomy or some sort of hierarchy to place the metadata, either automatically or without at all manually. This allows us to leverage the automatically generated metadata natively within certain applications. So auto-classification in our solution is automatically generated multi-term metadata. And as we just saw from my demonstration with the term environment, what this does is binds a certain number of documents in our corpus to the taxonomy hierarchy. Taxonomies and thesauri are the foundation of an auto-classifier. They provide the vocabulary against which the rules are built and teach the machine how to understand, normalize, and categorize content. So a statistical system uses words to determine important or useful concepts. You have to train a statistical system using a representative sample of documents, as we just did, normally sort of 50 or 100 for each concept of your taxonomy. And by feeding it some example text for each category, it can then analyze the text and extract statistically significant keywords and patterns. This method can require a lot of effort to create the training set and relies on the availability of keyword-rich text, but it does give us lots of benefits. The only real other problem is it sometimes can be difficult to identify why classification results are occurring, but that's why we need other tools as part of the classification set to help with this. Oh, sorry, jumped ahead a little bit there. So the other type of systems we might look at are rules-based systems. And what these rely on are fairly simple Boolean expressions looking at ands and ors and nots. And these categorization rules are looking for positive or negative evidence to match to a particular category. So an example that we could say is if we're looking for documents that conform to the term astronomy care, we'd be looking for the keyword mercury, but we wouldn't want it in proximity to the words car or chemical. The success of rule-based systems is heavily dependent on the richness of the taxonomy and collection of synonyms/keywords associated to each category. Weighting can be used to adjust how the system interprets the relevancy of a specific keyword or a specific category. The challenge is in creating and tweaking the rules for each category and keyword combination. It can be quite onerous, and again, given the nature of Boolean expressions, does tend to require IT involvement, whereas a statistical basis using suggestions doesn't necessarily need that IT involvement. In a perfect world, it is useful though to be able to leverage techniques from both branches. What this enables us is to have a combination of the more fuzzy statistical techniques with the more specific rule-based systems to ensure that we align the taxonomy structure to our business needs. So our classification engine can be broken down into 4 key areas. The first stage is the document preparation stage, and what this focuses on is extracting the largest amount of data possible from the document. The more data we can extract at this stage, the more accurate our classification results can be, given we have a higher burden of proof for whatever category we're assigning the document to. The second stage then takes this data and passes it into whatever engine is being used. So this may be a term-based approach or it may be a statistical approach, but whichever it needs to do, it will take that text and then pass it into a stage that the classification engine can then pick up. And what this means is that at the classification stage, it can fairly agnostically take the past data and apply it through the classification engine. The classifications can then be ranked and applied to the documents and then obviously benefit the source systems. So we've got a few different types of auto-classification system that we're going to look at. The first, as we've mentioned, is the keyword engine, which gives us our Boolean operator results. We then have the linguistic engine, which takes a lot of the difficulties away by automating a lot of the processing. But this does suffer the issue that I mentioned earlier, where it doesn't necessarily have an alignment to business goals, and the terms that it may produce, while statistically accurate, don't necessarily represent how the business is working at that time. So a good example might be if a business has a product that is being used for 10 years, and after a rebranding has a completely different name. Now, a linguistical technique is going to quite accurately find the old product name because that is a statistically relevant term and it's something relevant. However, from the point of view of normalization within the organization, it's useful to be able to map that to a new term, and that's what the statistical engines and the Boolean expressions can allow us to do, so that we can normalize our content and make it much easier for our end users so they don't necessarily have to find two different product references. They can just look at the most relevant new one. We also have semantic networks which define concepts and the relationships between them using a variety of rules to imply the relationships and infer context. These utilize a lot of business knowledge in their creation to improve the end result, so we know that all of the different relationships we have are accurate between the concepts and we have all of the relationships there, so we can draw inference from perhaps transitive relationships from one to another. The final system we're going to talk about here is machine learning. What this kind of system does is utilizes huge amounts of data analysis to then analyze your new content and predict classifications. Again, by its nature, it's a bit of a black box system and it's quite difficult to predict why it's doing something unless you're very, very good with maths. And what this means is that it can suffer with the same issues in terms of a lack of business alignment using whatever terms it can find that are statistically accurate. So, all of these systems to an extent use training sets to extract the relevant rules and statistics by which they then classify content. Exact matching will never deliver accurate classification results because no matter how much we attempt to determine how much a document is about each term, the majority of topics within the documents can't be prioritized. So what we need to do is use language techniques such as stemming and the identification of stop words to improve our keyword and phrase analysis, which we can then do to increase recall with little effort on the part of the end user. And it's using all of those kind of techniques that we then get the different sets of clues to build up our classification rule to apply. So what I'm going to demonstrate now is how an end user might perceive auto-classification and how beneficial that can be to an end user. So what we're going to do is step across to a SharePoint Online environment, and what I'm going to do is, pretending I'm an end user, upload a single document. Now in a typical scenario, or a typical manual classification scenario, what the end user would have to do is select the most appropriate terms from the taxonomy. Now in the case of this particular taxonomies that we're about to demonstrate, we're talking about several thousand nodes across the whole term set. So even if they have a quite in-depth knowledge of that document, what they might struggle with is knowing exactly which tags to apply because they might not know all of the tags that exist in the taxonomy. So what auto-classification does is, on the fly there, that document has been sent to a background server. The background server has applied that statistical engine that we have. It's looked for all of the different relevant terms and phrases within the document. And then it's applied classifications directly for the end user to be able to then review and apply to the document if they feel they are accurate. And what it's also done, as we can see here, is applied a couple of tags that identify this document as confidential. So that could be quite important in terms of security, so that you could have a process whereby as an end user uploads a document to perhaps a public site, we can have rules that identify that it's confidential and perhaps shouldn't be there. And that gives the user a chance to not check that document in, or perhaps another system such as records management or security software can then pick that up and deal with it as is necessary. So I think this demonstrates how powerful auto-classification can be for the end user in terms of optimizing their time usage. So hopefully the demonstration did illustrate the power of adding additional metadata when organizing our content. And it's this power that's the driving force behind a taxonomy being our end goal. Our documents can be classified to one or more nodes in the taxonomy based on the defined rules and statistics. And once we've classified that taxonomy across all of our documents, we can then use it as a hierarchical objects browser for our content. So the diagram on the right depicts a fairly typical database structure for a taxonomy. In this case, this is the WordPress plugin. We can see definitions for the taxonomy hierarchy and relationships between the nodes. It's also worth noting that there are multiple different types of taxonomy. We tend to suggest using subject-based taxonomies, which are created by domain experts, so the business owners of the documents. They tend to provide the best results. But what we can also look at are content taxonomies, which are built by organising the data that we're already storing and then structuring the taxonomy around existing metadata such as file size or authors. We also then have behaviour-based taxonomies, which focus on many different areas, typically using elements of artificial intelligence to analyse what users are doing when they manually tag documents and when they apply search queries. There are arguably other attributes that we can look at to describe taxonomies, one of which is a pick list or perhaps a set of controlled vocabulary rather than allowing end users to just specify as many terms as they like. Another key definition though really is whether a taxonomy can be described as hierarchical, because it's not necessarily a hierarchical taxonomy. It can be a flat structure, for example, which also leads us to another potential attribute known as a polyhierarchy. And within such a taxonomy, a term can live in one or more places. The most common example of this is perhaps the term piano in a scheme of musical instruments. It's both a stringed instrument and a percussion instrument. So it can sit in two different places, and this enables us to be more accurate in the way that we classify documents. Finally, we have ontologies, which provide not only the set of concepts that we have in the taxonomy, but also the really complex relationships that we have between them. By this nature, I tend to find them best described as a flexible graph rather than a hierarchical set of terms, because there are these additional relationships. We don't just have the parent-child, we also have perhaps, Bob is an employee of Mike. Mike is the employer of Bob. And it's the multiple relationships that allow us to build up our inferences there. So apologies at this point for what is a bit of a short sales pitch, but what I'm going to show you now is how easy it can be to set up an ODNA taxonomy, and two features that we feel are fairly unique and beneficial in helping you test terms for accuracy when building classifications. So I'm going to go back to the environment that I was in before, and I'm going to look at creating a new term. So the term that we're going to create is called farming. So this could be beneath environment, or it could be at the same level. Now when we first create this metadata term, this won't be applied to any documents, nor does it have any ways in which we can infer that any document should be applied to it. So what we're going to initially start off with is doing the same process that we essentially did before in identifying some documents that should be about farming and seeing what sort of terms we can get back from them. So what we're going to do first of all is do a search for the term farming. And this is going to bring back, hopefully, a number of documents, and we can see here we've got 193 results. So what we can then do to aid the building out process is what we did before. Take a set of these documents and then suggest clues from them. So again, this is doing the reverse statistical analysis and identifying the content that's most useful. So as we go through, we can see that we've got a slightly smaller set of content here, so we're getting some more odd results, but what we are getting is some quite relevant results. So we're seeing husbandry, which is definitely relevant to farming. We have sheep stocks. We have, if we go through, I'm sure we'll find some other ones. Arable land. Bracken, I suppose, to an extent. But what this is trying to identify is that we definitely can find terms that the end user can then select that he might not necessarily understand what they are, but as long as he's got some knowledge of the business area plus these samples, they can quite easily select some clues. The final part of the demonstration that I'm going to show here is how we can then get immediate feedback. So what I'm going to do is once again search for the term farming, and then I'm going to apply what's known as document movements. And what this does is an on-the-fly classification of our content so that we can see exactly what's going to happen to the documents we've got. So as we go down, we can see that the documents at the top are going to stay unclassified. This will be because they don't contain the words that I just added to define what should be tagged as farming. But what we can see a little bit further down is this particular one here is being scored at 112 now, so it's now going to enter the classification range. And what we can also do at a more granular level is view the calculations to see exactly which compound terms were identified to see why that should be tagged as that term. And it's using this iterative process of analysing the content that we've got and the classifications and calculations that are achieved and the suggestion interface to pull out the relevant and statistically relevant terms that we can very quickly and easily build up some classifications and get a pretty precise and relevant taxonomy that has a good level of recall. So what we're going to do now is put back to the slideshow. So towards the end, what we're going to discuss now is our infrastructure and coordination natively with SharePoint. So the previous demo in our interface, all of the taxonomies were actually stored in SharePoint, and all of the changes were directly written back to SharePoint. So for most SharePoint organizations, most if not all are probably familiar with the term store. The problem is with it, it's a bit rudimentary, it is quite manual, and it can be prone to error, particularly when the end users are allowed to create the metadata on demand. The crux of the issue is that SharePoint itself can't generate metadata, can't also classify, and can't generate concepts. And for this reason, we feel it's crucial that when identifying a product that works with SharePoint, it must natively support the term store. So the term store itself was introduced in 2010, for those that don't know too much about it. It's a metadata store that allows hierarchical taxonomies but not polyhierarchical taxonomies, and it has lots of API functionality to enable you to store additional information about those terms, work in multi-languages, and then, as we've seen, work with these different products. So the final issue that we tend to find with the term store is that it provides little ability to synchronize the term sets across environment, save for a fairly recently released feature, which is the hybrid synchronization. Now the sync is important because we want to ensure that any taxonomy changes we make can be replicated between our multiple environments, if we have multiple environments, without manual intervention, particularly as large business changes are made. So a good example of this might be if we have an on-premise SharePoint environment for our very sensitive content and an online environment for our less sensitive content. We would want to regularly synchronize the taxonomies between them. What we also might want to do is have a development environment where we can test all of our business changes, and then once we're happy that there are no mistakes, we can roll those out to production. And again, what we don't want to then have is manual intervention, because if we have that manual intervention, what we risk is that while we tested it heavily in dev, a mistake is made when it's brought across. It's important to note that the SharePoint term store stores all of its terms with a particular unique GUID, effectively is what it's known as, a globally unique identifier. And what this means is that the term itself, despite perhaps changing in name, can be identified very easily. And it's important that we maintain those GUIDs across the environment so that as content moves around, it retains the same terms and it retains the same IDs. It's also important so that we can do a proper differential check between the taxonomies when we sync between environments. So to assist with this process, we provide a tool that allows you to synchronize across different farms and SharePoint Online tenancies. So it's one of the last few steps today. What I'm going to do is do a very short demonstration of how easy this product can be to keep your taxonomies in sync. So what we're going to be doing is synchronizing the new term that I created here, farming, across to one of our Office 365 tenancies. So if I refresh the page now, what we should see is that it's got the term environment, but it doesn't contain the word farming. So just bear with the SharePoint Online being a little bit slow here. And then we'll be able to just very quickly check that it definitely doesn't contain, and I'm not cheating. So if we expand 365 taxonomies, in there we have our demo taxonomy with just the word environment, or just the term environment. So what I'm going to do is take our synchronization tool, use the history functionality to repeat the synchronization I did earlier, which allows me to synchronize between my 2016 environment and my SharePoint Online environment. So once I've entered the passwords, what this is going to then do is have a check of what's in the source environment, have a check of what's in the destination environment, do a comparison and try and identify what it feels are the most logical term sets for synchronization. And the way it does this is by comparing the unique GUIDs that aren't actually unique across the two environments, so the IDs that match. What we can see is that it's automatically selected my demo term set because that's a matching GUID. So what we're going to do is then click Next again and then click Begin. And what this is going to now do is do a comparison of the structure in 2016 and then look at that versus the Office 365. And what it should find is that it needs to create one term in the destination environment. So there we go, we can see it's added and updated, and the reason for the update is because of the new clues that I added to the environment term. So we can then see it's added the farming term and that's gone up there. So if I then refresh the Office 365 environment, what we should see is that the farming term is being created automatically within the term store. So that demonstrates just how easy it can be with this tool to get the metadata across. What we can also do is schedule that tool to run on an automated basis so that we don't have to have manual intervention, and all of that can be done from the command line. Right then, so to wrap up, organisations, primarily at the upper management level, tend to overlook the high cost of not managing their content. And the above on this slide are just a few of the areas that metadata can impact. But other applications not included are things like migration, collaboration, eDiscovery, and text analytics, all of which are obviously very important that we get all of the right content back, particularly eDiscovery from a point of view of risk management. On the left-hand side of this slide, we have a list of the applications that are most impacted by metadata. And on the right, what we can see is an expected return on investment for automating the management of the metadata. This does make the assumption that you have a solution in place, but it's highly dependent on the solution. And what we would recommend is that if you're evaluating products, we would recommend that you insist on a proof of concept and include multiple vendors so that you can get a meaningful comparison between both the classification results and how easy they are for your end users to proceed with. So I hope you've enjoyed today. Our next webinar is going to be given by our strategic partner CDH. So if you'd like any more information on that, please check our upcoming webinars area for more information on this webinar that's going to be to do with enterprise search. Again, thank you for joining us today, and as I mentioned at the start, we will be sending out a copy of the webinar and the slides in the next couple of days, along with the responses to any questions that have been raised. However, if you have any further questions, please feel free to reach out to either myself or our marketing team, and have a great week. Thank you very much.